Section 3 of the Science, History of the Universe, Volume 4. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Science, History of the Universe, Volume 4, edited by Francis Ralt Wheeler. Chemistry, Chapter 3. The Early Alchemists. The origin of alchemy undoubtedly is to be sought for in remote antiquity, as mythical tradition reveals the sources from which the belief in the transmutation of metals was nourished, and the primary historical sources are rare and obscure. However, it appears that alchemy was pursued as a secret science held in honor among the Egyptians, Chaldeans, and other nations. The almost universal tradition among alchemists is that their art was first cultivated among the Egyptians, and when it is recalled that ancient Egypt was a country where the chemical art was widely practiced, it is not surprising that the earliest records of alchemy are to be found there. Clement of Alexandria states that the knowledge of the art was confined to the priests, who were prohibited to communicate it to any but the heir apparent to the throne, and to such among the priestly caste as were virtuous and wise, and Plutarch mentions that the strictest secrecy was observed. It would seem that the art of alchemy was especially cultivated at Memphis, and Tomer, the high priest of Memphis, was so great an adept that he was said to be familiar with all things. The first dominant personality with which the origin of alchemy is associated is that of Hermes Trismegistus, and the alchemists acknowledge him as one of the earliest masters, if not the originator of their creed and craft. This Hermes, some assert, is identical with Canaan, the son of Ham, and the name is synonymous with the old Egyptian godhead Thoth, which, when endowed with the serpent staff as the symbol of wisdom, was compared by the Grecians with their Hermes. Hermes Trismegistus was said to be the author of 20,000 or more books, which probably indicates that, as the god of letters, all books were dedicated to him, and in Roman Egypt, pillars were erected in his honor, upon which alchemistic inscriptions were put in the form of hieroglyphs. In the 11th century, the alchemist Hortulanus announced the Latin version of an essay which he ascribed to Hermes. This came to be known as the Smaragdine Table, or Tabula Smaragdina, and it is probably one of the earliest of the Hermetic philosophical or alchemistic writings. An English translation of this essay, made by F.G. Weichmann in his Chemistry, Its Evolution and Achievements, is as follows. True it is, without a lie, sure and most true, what is below is like that which is above, and what is above is like that which is below, of one substance to perform miracles. And as all things have come from one being, the mediation of one, so all things have been generated from this one thing by adoption. Its father is the sun, its mother is the moon, the wind has carried it in its womb, its nurse is the earth. The father of every talisman of the whole world is this. Its power is unimpaired when it is turned upon the earth. Separate the earth from the fire, the subtle from the material, gently, with great cleverness. It rises from the earth to heaven, and again descends upon earth, and receives the force of those above and those below. Thus thou wilt have the glory of the whole world. All obscurity, therefore, will leave thee. This is of all strength, the strong strength, because it will subdue every subtle thing and penetrate every solid. Thus has the world been created. Hence there will be wonderful adoptions whose measure is this. Therefore I have been called Hermes Trismegistus, possessing 3 parts of the philosophy of the whole world. What I have said of the operation of the sun has been fulfilled. This essay is obscure enough to receive almost any interpretation. The Chaldeans, who were masters of occult sciences, undertook the fusion of astrology and magic, and the belief in the connection between the sun and the planets and the metals, which was assumed for a long period, was of Babylonian origin. It was believed that the planets influenced the growth of the metals, and the signs of the heavenly bodies became the symbols of the metals. In fact, The metals were called by the names of the stars up to the end of the 18th century. One writer of the 5th century AD states that gold corresponds to the sun, silver to the moon, lead to Saturn, tin to Mercury, iron to Mars, and copper to Venus. In the 13th century, symbols were used freely to denote some of the metals, as for example, gold, Sol, was represented by a circle with a dot in its center. Silver, Luna, was depicted by a crescent, and copper, Venus, was denoted by the symbol used by Glauber at a later date. Many of the alchemists saw in these symbols an indication of the metals they represented. Thus the circle illustrated perfection of the metallic condition, while the semicircle indicated only an approximation to this state. Some have supposed that the symbol for copper, Venus, represented a hand mirror, and this is highly probable. The Jews, who were believers in magic, played an important part in the fusion of Eastern and Western doctrine at the time of the birth of Christianity, and some writings on alchemy have been ascribed to Jewish writers. The later alchemists record various biblical characters as alchemists on the authority of the Bible, as Adam, Tubal-Cain, Moses and his sister Miriam, and John, and referred the origin of alchemy to the time before the flood. Democritus, 406 to 357 BC, is the earliest historical personage connected with alchemy, but it is not known how much of the alchemical knowledge of the ancients should be assigned to him. His name is found in the magic ritual of the Leiden Papyrus, found in Thebes in the 3rd century AD. And, according to Pliny, he received instruction in magic from Ostanes the Mede. During the first centuries of the present era, the transmutation of copper into gold was thought to be an ascertained fact, and the works of Pliny, Dioscorides, Zosimus, Aeneas Gazaeus, and Themostus Euphrates furnish records of this belief, which probably originated in the production of alloys possessing the color of gold or silver. Kopp has pointed out that it is probable in early times a plating of gold or silver may have been considered an actual transmutation of the covered object. In the early part of the Christian era, alchemy attained much notoriety and was fostered by the Church. In fact, the records of alchemy go on increasing from this era, and the savants of the time have left us fragments of their works. First among the alchemists of the early part of the Christian era is Zosimus, who lived in the 3rd century. In his Manipulations, comprising 28 books, he speaks of the fixation of mercury, of a universal medicine, and of a tincture which possessed the property of converting silver to gold. Zosimus is spoken of with great esteem by the later alchemists, and his mystical language exercised a pronounced influence on the Alexandrians and medieval alchemists. Synesius, bishop of Ptolemais, wrote commentaries on the works of Zosimus. He lived in the 4th century. Olympiodorus, a native of Thebes, reproduced the philosophy of Thales and Anaximenes, and was the first to distinguish matter according to its combustibility. His works, however, do not contain any certain information with regard to definite operations. Until the 4th century, Alexandria had been the center of science and philosophy, but under Roman rule it gradually declined, so that at this time only the Temple of Serapis was left. This temple, which was the bulwark of medical and alchemical study, however, was destroyed in the reign of Theodosius, so that many books which would have been invaluable for the history of chemistry were lost through its destruction. The Serapeum of Memphis and the Temple of Ptah also were destroyed at the same time as the Temple of Serapis, and it is only due to the relations which before then were developed between the Egyptians and the Byzantine Empire that all acquaintance with chemistry was not obliterated. Notwithstanding these catastrophes, the knowledge of some chemical operations continued to exist in Egypt, even though the light of science was gone and adepts no longer taught their cult, and the conviction that the base metals could be transmuted into gold and silver with its alluring possibilities still remained a feature of Egyptian thought. At the period when ignorance and barbarism prevailed through every part of the Roman Empire, Greek learning found an asylum among the Saracens. About the middle of the 8th century, the second prince of the Abyssinian dynasty, the Caliph al-Mansur, founded the city of Baghdad, and the light of philosophy dawned upon Arabia. Al-Mansur studied astronomy under the direction of 2 Christian physicians at his court, and offered liberal rewards to those who would undertake the translation of the Greek works on philosophy and science, which work was executed by the Christians then resident in Baghdad. He also founded a university at Baghdad, and pupils and professors flocked to it from all parts. Greece, Persia, and India were taxed to help the Arab mind, India especially providing many alchemical notions. The succeeding caliphs, Harun al-Rashid and al-Mamun, also were liberal patrons of learning of every kind, and under the caliphate of the latter, the light of philosophy shone forth in meridian splendor. Science continued to enjoy the protection of the Saracen princes even after the empire was divided into several caliphates, and was, by means of their conquests, disseminated throughout the greater part of the world. From the beginning of the 9th to the end of the 13th century, when the power of the Saracens yielded to that of the Turks, schools of learning flourished in the empire, and the college at Baghdad contained 6,000 masters and scholars at the beginning of the 12th century. About the year 1000, 20 schools were instituted at Cairo, and learning was imparted to a multitude of pupils. Academies were also founded in Africa and Spain, and these were distinguished by eminent philosophers when barbarism universally prevailed among the Western Christians. The library of the University of Cordova contained 280,000 volumes, and it is said that this university produced 150 authors. Although Islamism prohibited magic and all arts of divination, alchemy applied to the preparation of medicines was ardently studied, and it found its way to the other Western nations, where from the Arabian universities in Spain it attained its full development in the 13th century. The first of the alchemical adepts who appeared during the Christian era was the so-called founder of experimental chemistry, Abu Musa Jafar al-Sofi, afterward known to the Western nations by the name of Gerber. This alchemist is supposed to have lived in the 8th century, but his life is involved in hopeless obscurity, and he has sometimes been confused with Discabir of Tharsis. However, some historians of chemistry have ranked him first among the chemists and alchemists who flourished prior to the time of Van Helmont, and it has been remarked that Gerber is to the history of chemistry what Hippocrates is to the history of medicine. No less than 500 treatises have been attributed to Gerber, and these were supposed to have included all the physical sciences. But the recent researches of Berthelot and others have proved that the Latin writings hitherto ascribed to Gerber could not have been written by him. The oldest of these writings, the Summae Perfectionis Magisteri in sue naturae libri quatuor, was not written till the middle of the 14th century, and it appears that the De Investigatione Perfectionis Metallorum, which was formerly thought to contain 2 important literary productions of Gerber, his Testament and a tract on the construction of furnaces, belongs to an even later date. Berthelot further has shown that the Arabic manuscripts of the authentic Gerber prove that he did not really profess the remarkable knowledge attributed to him, but that he adhered to the Greco-Alexandrian alchemists. His real views were mystical. For instance, he believed in the influence of the planets upon metals, and his reasoning was mostly from premises which now appear defective. The Latin treatises, with which, until the investigations of Berthelot, the name Gerber has been connected, contain views on sulfur and arsenic, and on the transmutation of metals. In fact, they would make it seem that the object of his work had been the discovery of the philosopher's stone, but it is now known that these writings contain the collected knowledge of the 4 or 5 centuries after the time of Gerber. Rhazes, whose true name was Mohammed Ebn Sakarja Abu Bekr Arazi, was a celebrated disciple of Gerber. He was born about the year 850, and no less than 226 treatises are said to have been written by him. These writings discuss the influence of the stars on the formation of metallic substances beneath the earth, and contain, some assert, the first mention of borax, orpiment, realgar, and certain combinations of sulfur, iron, and copper, as well as some salts of mercury and compounds of arsenic. Figure. He believed in the transmutation of metals, and undertook to perform a transmutation before Emir al-Mansur, Prince of Khorasan, after the latter had spared no expense in providing the necessary apparatus and materials for the accomplishment of the magnum opus. He failed miserably, however, and subsequently died in poverty and obscurity. The next great Arabian scientist was the illustrious Ibn Sina, generally called Avicenna, who was born about 980. He is believed to have died in the year 1036, although several Oriental peoples assert that he is still alive and enjoying the nectar of perpetual life and untold wealth, results of the supercharged power of the Philosopher's Stone. 6 or 7 treatises on alchemy have been ascribed to Avicenna. One of these, the Tractatulus Alchemiae, treats of the nature of mercury, which Avicenna regarded as the universal vivific spirit, capable of penetrating, developing, and fermenting. Avicenna undoubtedly derived his chemical knowledge from Geber. According to Waite, he describes several varieties of saltpeter and treats of the properties of common salt, sulfur, orpiment, vitriol, and sal ammoniac. Among the other disciples of Geber may be mentioned the Arabian physicians Aben-Zoar, Averroes, Maslima, and Abu Qasis, and the philosopher Al-Farabi. Aben-Zoar, who lived in the 11th century, is said to have made some additions to the knowledge of medicinal preparations, while Averroes, a physician celebrated for his personal virtues, attempted to improve the theory of medicine by the aid of philosophy and attained some prominence as a chemist. A North Persian physician, Abu Mansur, wrote a work on the principles of pharmacology, by which may be ascertained the chemical knowledge of the time, but it appears that the Arabian alchemists of the 11th, 12th, and 13th centuries mostly devoted themselves to attempts at transmuting the base metals into gold. These alchemists, in the main, were of little prominence and contributed nothing new. At the beginning of the 7th century, almost the whole Western world was overwhelmed with intellectual darkness, and in the 8th century, philosophy and learning seemed ready to expire among the Greek Christians. However, the spirit of barbarism, which possessed many of the reigning emperors, was not characteristic of the reigns of Michael, Bardas, and Constantine Porphyrogenites, all of whom, excited by the example of the Saracen caliphs, recalled and encouraged learning. Constantine was himself, in the 9th century, the pupil of the Byzantine scholar Michael Psellus, who contributed to the propagation of alchemistic ideas. From the 11th to the 15th century, philosophy and learning were much neglected in the Greek Empire, but at the time when Constantinople was taken, 1451, there were several learned philosophers among the Greek Christians. These were obliged to leave their monasteries, however, and this circumstance occasioned the return of Grecian learning into Europe, for after the Greek Empire was destroyed by the Turks, the friends of literature and science fled into Italy, taking with them many of the Egypto-Greek and Arabian alchemistic doctrines. Notwithstanding the fact that the decadence of Saracen power in Europe was rapid after the expulsion of the Arabs from Spain, yet for some centuries the influence of Arabic thought was great. The works of the Arabians were translated and widely disseminated, and the modes of their thought and work imitated. Then, too, the returned Crusaders aided in the spread of Eastern learning, and many industries were founded by them. They were particularly interested in alchemy, however, and as the nobles were impoverished and desired to replenish their treasuries, attempts at transmuting the base metals into gold became more than a craze. It became the cardinal point toward which all chemical knowledge was directed. Many Christian princes were imposed upon by pretending possessors of the Philosopher's Stone. It is especially interesting to note that the first appearance of an alchemist at a German court was about the year 1063, when a baptized Jew announced to Adalbert von Bremen that he had acquired in Greece the knowledge of transmuting copper into gold. It was during the 13th century that learned men gave their attention to the study of alchemy, and consequently the art reached a high degree of development. These scholars considered that the transmutation of the metals was a settled fact, and maintained the existence of the philosopher's stone, and some of them, Albertus Magnus, Thomas Aquinas, Roger Bacon, Arnold Villanovanus, and Raymundus Lullius, greatly influenced the development of chemistry by their pursuit of alchemy in the scientific spirit. Albertus Magnus, 1193–1280, was a scholastic theologian, but his genius and curiosity did not allow him to pass by the Hermetic science without giving it attention. In fact, he was the first German chemist of prominence, and is ranked as a skillful practical chemist for the period in which he flourished. He became a Dominican friar in 1221, and from this time he was an instructor in philosophy, grammar, alchemy, and natural history at Cologne, Paris, Hildesheim, and Regensburg. Michael Meyer, a later writer on alchemy, states that Albert acquired the secret of the philosopher's stone from the disciples of Saint Dominic, and that he communicated it in turn to Thomas Aquinas. Meyer further declares that for 30 years Albert employed his knowledge as an alchemist and astrologer to construct, from metals selected under proper planetary influences, an automaton having the power of speech. This was the curious android, which was said to reply to every question proposed to it, and which Thomas Aquinas destroyed under the impression that it was a diabolical machine. Albert is also said to have suddenly reproduced the flowers and softness of spring in the midst of winter for the entertainment of William II, King of the Romans, when the latter dined in the monastic house at Cologne. The views of Albert are in the main those of the Arabian school, although he added many new chemical facts. He mentions alum, caustic alkali, red lead, arsenic, green vitriol, iron pyrites, and liver of sulfur. He knew that arsenic renders copper white, and was familiar with the method of purifying the precious metals by lead. He found that sulfur attacks all the metals then known except gold, and designated the cause of this combination by the term affinitas. In his De Rebus Metallicis et Mineralibus, Albert states that he tested some gold and silver, said to have been manufactured by an alchemist, and which resisted 7 fusions, but that the pretended metal was reduced to a scoria by an 8th fusion. He distinctly recognized the possibility of transmutation, however, when the operations were performed on the principles of nature, and considered that all metals are composed of an unctuous and subtle humidity, incorporated with a subtle and perfect matter. That is, the metals are all essentially identical, differing only in form. In one portion of his De Alchemia, he asserts that gold is produced by the action of pure sulfur on pure mercury, by the permanent action of nature and after more or less time. Thomas Aquinas, 1225–1274, the universal and the angelic doctor, was a Dominican friar and disciple of Albertus Magnus, and taught at Paris and Naples. Several works on alchemy have been ascribed to him. In one of these, the Thesaurus Alchemiae, he states that the aim of the alchemist is to change imperfect metal into that which is perfect, and moreover asserts that such a transmutation is possible. The other works of this character attributed to him are Secreta Alchemiae Magnalia and De Esse et Essentiae Mineralium. He wrote on the manufacture of artificial gems, and some of the terms still in use by modern chemists occur in the supposititious writings of Aquinas, as, for example, the term amalgam for alloys containing mercury. Roger Bacon, 1214–1294, the wonderful doctor, was born at Ilchester in Somersetshire, England, and studied at Oxford and Paris. It is said that he studied history, learned the Oriental and Western languages, and gained a knowledge of jurisprudence and medicine, subjects to which little attention was given in his time, and in order to prosecute his studies without interruption, he assumed the monastic life in the order of St. Francis. He employed his time not in the controversies of the day, but in researches into the properties of natural bodies, and by the aid of mathematical training and experiment, he acquired a knowledge of mechanics, statics, and optics. His success in physics and in the construction of automata kindled a spirit of envy among the monks of his fraternity, and this led to the circulation of a report that he held converse with evil spirits, causing him to be imprisoned for 10 years. He also knew how to use convex lenses for telescopic and microscopic purposes, and drew attention to the error which occasioned the Gregorian Reformation in the calendar. Bacon was familiar with many processes in chemistry, and doubtless would have produced great discoveries in this science had he not been drawn aside from the path of true investigation by the philosophical ignis fatuus, which led the philosophers of this age to attempts at transmutation. He believed in the philosopher's stone, and his views on the transmutation of metals may be illustrated by the following quotation from his Speculum Secretorum. To wish to transmute one kind into the other, as to make silver out of lead or gold out of copper, is as absurd as to pretend to create anything out of nothing. The true alchemists never held such a pretense. What is the real problem? The problem is, first, by means of art, to remove from the rough, earthy mineral a bright metallic substance, like lead, tin, or copper. But this is only the first step toward perfection, and the chemist's work must not stop there, for besides that he must look for some means of getting the other metals, which are always present in the bowels of the earth, in an adulterated condition. For example, the most perfect is gold, which one always finds in the native state. Gold is perfect because in it nature finished her work. It is necessary, then, to imitate nature, but here a grave difficulty presents itself. Nature does not count the cycles which she takes for her work, to which the term of life of a man is but as an hour. It is, then, important to find some means which will permit one to do in a little time that which nature does in a very much longer time. It is this means which the alchemists call indifferently the elixir, the philosopher's stone, etc. Bacon also stated, with the help of Aristotle's secret of secrets, experimental science has manufactured not only gold of 24 degrees, but of 30, 40, and onward according to pleasure. The application of the study of alchemy to the extension of life was another subject of study with Roger Bacon, and he states that the operation by which the base metals are purged from the corrupt elements which they contain till they are exalted into gold and silver is considered by every adept to be calculated to eliminate corrupt particles of the human body, so that the life of mortality may be extended for several centuries. The chemical investigations of Bacon have proved valuable, but the above-mentioned alchemistic ideas seem incomprehensible to moderns when contrasted with his other views and knowledge. Gunpowder-like mixtures were within his knowledge, and according to some, names sulfur and saltpeter as two constituents, while the third constituent he denominates under the anagram Luru Mone Cap Ubre. He probably derived this knowledge from some Arabic source. The Arabs were acquainted with gunpowder-like mixtures as early as 1280, and the knowledge of the propelling force of such mixtures came about between 1313 and 1325. Gutmann states that the so-called ancient records concerning the invention of gunpowder should be approached with great caution, since manuscripts of doubtful date and origin have been inadequately translated to serve various nations as proofs of their claim to this invention. Bacon found that saltpeter could be purified by solution in water and crystallization. He subjected organic substances to dry distillation and observed inflammable vapors were produced, and he called attention to the fact that air was necessary for the burning of a lamp. All these facts, together with many others, Roger Bacon learned by experiment, and he is to be regarded as the intellectual originator of experimental research. His important works are as follows. Opus Meius, de secretis operibus artis et naturae, Radix mundi, speculum secretorum, secretum secretorum, breviarum de dono Dei, and Alchemia maiorum. The alchemistic tendencies of the 13th century are distinctly reflected in the work of the two celebrated adepts, Arnaldus Villanovanus, Arnold de Villanova, and Raymundus Lullius. Yet much uncertainty exists in regard to the life of the latter and to the works ascribed to him. Nevertheless, both exercised no small influence on their generation, and they were held in high esteem on account of their methods and labors. Arnaldus Villanovanus, 1245 to 1310, whose birthplace is uncertain, studied medicine at Paris for 20 years, after which he traveled through Italy, visiting the various universities. He subsequently went to Spain and practiced as a physician in Barcelona, but learning that Peter d'Apono, a friend, had been seized by the Inquisition, he withdrew to Sicily, where he wrote his tracts on medicine under the patronage of Frederick II, King of Naples and Sicily. Arnaldus was, however, charged with magical practices, and in 1317 the Inquisition of Tarragona condemned his books to be burned on account of the heretical sentiments they expressed. He was an adherent of the Arabian school, believing in the composite nature of the elements and in the transmutation of the metals, and his skill in the Hermetic philosophy was recognized by his contemporaries, one of whom wrote, "In this time appeared Arnold de Villanova, a great theologian, a skillful physician, and wise alchemist, who made gold, which he submitted to all proofs." Arnaldus believed that quicksilver was the medicine of all the metals, that sulfur was the cause of their imperfections, and that the philosopher's stone existed in all bodies. He was acquainted with oil of rosemary and oil of turpentine, and conducted distillations in a glazed earthen vessel with a glass top. He was probably the first to point out the poisonous nature of decaying flesh. He made external application of various mercurial compounds and understood some of the properties of alcohol. His knowledge of poisons was extensive. The principal works of Arnaldus are Rosarius Philosophorum, Flos Florum, Antidotarum, De Vinis, and De Venenis. Raymundus Lullius, 1235 to 1315, was descended from an old and noble Catalonian family, and led a varied career. According to Waite, in his Lives of the Alchemistical Philosophers, he united the saint and the man of science, the philosopher and the preacher, the apostle and the itinerant lecturer, the dialectician and the martyr. In his youth he was a courtier and a man of pleasure. In mature age he was an ascetic who had discovered the universal science through a special revelation from God. After his death he was denounced as a heretic, and then narrowly escaped beatification as a saint. He was probably initiated into the secrets of alchemy by Bacon and Arnaldus. In all, about 500 works have been ascribed to Raymundus, but there is very great uncertainty whether he is identical with the grammarian and dialectician of the same name, and, moreover, the errant life which he led could have afforded him few opportunities for the investigations involved in the search for the magnum opus. Therefore it is supposed that many of his writings are spurious, although 3 of his alchemical writings, the Testamentum, Codicillus seu Vadamecum, and Experimenta, are regarded as genuine. His alchemistic doctrines are obscure and mystical, and this led many to think that wonderful facts were concealed in his treatises. Raymundus attributed remarkable powers to the philosopher's stone, for he was able to say, "If the sea were of mercury, I would change it into gold." He also affirmed that health, long life, and precious stones were to be procured through its means. The alchemist, styling himself Raymundus Lullius, was acquainted with nitric acid, and used it to dissolve certain metals, and he prepared aqua regia by adding sal ammoniac or common salt to nitric acid, and was aware of its dissolving gold. Grulin, in his Geschichte de Chemie, states that Lullius was acquainted with spirit of wine, and that he prepared vegetable tinctures by its use, and alum from Rocca, white and red mercurial precipitates, cupellate silver, marcasite, and oil of rosemary are mentioned in the works of alchemy attributed to him. Among the other alchemists of this period were Jean de Meung, the monk Ferrarius, and Pope John XXII. The latter is claimed as an adept by alchemists, but his orthodox biographers denied that he had any alchemistic inclinations. At his death in 1334, he left in his coffers 18 million florins in gold and 7 millions in jewels, and the alchemists attribute these treasures to his skill in their science. In the 14th and first half of the 15th centuries, many alchemists were supposed to be in possession of the Philosopher's Stone. The prominent alchemists of this period were Nicholas Flamel, Peter Bono, Johannes de Rupecissa, Isaac of Holland and his son Bernard Trevisan, John Fontaine, Sir George Ripley, Thomas Dalton, and Thomas Norton. Owing to the fact that alchemy was encouraged at many of the European courts at this time, many charlatans sprang up, pretending to be able to make gold without limit, and in some cases the frauds attempted were discovered. Nevertheless, alchemy was not suppressed, and it found especial protection at the court of Henry VI of England, notwithstanding the fact that in 1404, by an act of Parliament, it was forbidden to make gold or silver, as the preceding monarchs had had to pay heavily for their encouragement of the art. As early as 1344, Edward III had coins struck from gold, said to have been made in the Tower, and later large quantities of counterfeit gold coins were manufactured. The alchemist Lecour seduced Charles VII of France into a similar experiment during a war with England, which only resulted in increasing the national debt. This counterfeiting caused much discredit to be attached to alchemy, and the result was that this was extended to chemistry itself. However, the knowledge of chemical compounds and operations was enriched during this period by some valuable experimental observations, and toward the beginning of the 16th century, chemical knowledge was greatly extended. End of section 3. Section 4 of the Science, History of the Universe, Volume 4. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Science, History of the Universe, Volume 4, edited by Francis Ralt Wheeler. Chemistry, Chapter 4, The Later Alchemists. Until lately, the marked progress in chemical knowledge which occurred toward the end of the 15th century and at the beginning of the 16th century was always associated with the name of Bacillus Valentinus. But the authenticity of the writings ascribed to him has become more and more questioned, and they are evidently spurious in parts. He seems to have been born at Mayence about 1394 and to have been a monk of the Benedictine order. But although numerous works have been printed in his name, no further particulars concerning his life have descended to posterity. The important works which appear under his name are as follows: Cursus Triumphalis Antimonii, De Microcosmo, De Que Magno Mundi Mysterio et Medicina Hominis, Tractatus Chemico, Philosophicis de Rebus Naturalibus et Praeternaturalibus Metallorum et Mineralium, Practica una cum duodecim clavibus et appendici, De Magno Lapide Antiquorum Sapientum, and Testamentum Ultimum. It is impossible to extract from these works the knowledge gained and possessed by the original author, but as von Meyer states, there can hardly be any doubt that a large number of facts were recorded by the writer who lived about 100 years before the books were published, this being especially the case in the Triumphal Car of Antimony, in which we possess what for a time was a marvelous description of an element and its compounds. In this work the extraction of antimony from the sulfide found in nature is described, and the properties of antimony are in part mentioned. Antimony was used in purifying gold, and its compounds were applied medicinally. It would appear that Basil Valentine was the first to prepare hydrochloric acid by heating together copperas and common salt, and that he was acquainted with the rectification of the distillate obtained from beer and wine by means of potassium carbonate, the use of precipitation as a method of experimenting, and the employment of the spirit lamp in certain operations. Judging from some passages in the works ascribed to him, Basil Valentine made the first attempts at qualitative analysis, for he proved that iron was present in certain hard tins, gold in Hungarian silver, silver in Mansfield copper, and copper in Hungarian iron. The language used in the works of Valentine is frequently obscured by mystical pictures and ideas, and, like others of his time, he often found it impossible to express his alchemistic thought in any language save that of far-fetched allegory. The 16th century, a period of reformation, adventure, and discovery, is characterized by the Paracelsists, who formed the transition from the alchemists of the Arabic school to the iatro-chemists. The latter had other objects of research than the alchemists, but as some of the Paracelsists and medical mystics were Hermetic philosophers, it is appropriate to refer to their alchemistic views here. Paracelsus, the Luther of medicine, the seer of Hohenheim, created a new school of alchemy. He considered that gold could be made by application of chemistry, but that the process is not to be compared with the method of producing gold by an exercise of the occult powers existing in the soul of man. On adopting this view, Paracelsus, with alchemistic tendencies, abandoned experimental investigation and sought within themselves the great secret of alchemy. Libavius, who criticized the mystical writings of Paracelsus, nevertheless fully believed in the transmutation of the metals, and even Van Helmont, the most distinguished of the iatro-chemists, went so far as to testify that he himself had effected the transmutation of mercury into gold. In his work De Vita Aeterna, according to Waite, Van Helmont makes the following declaration: I have seen and I have touched the philosopher's stone more than once. The color of it was like saffron in powder, but heavy and shining like pounded glass. I had once given me the fourth part of a grain. I call a grain that which takes 600 to make an ounce. I made projection therewith, wrapped in paper, upon 8 ounces of quicksilver, heated in a crucible, and immediately all the quicksilver, having made a little noise, stopped and congealed into a yellow mass. Having melted it in a strong fire, I found within 11 grains of 8 ounces of the most pure gold, so that a grain of this powder would have transmuted into a very good gold 19,156 grains of quicksilver. He states further that he performed a similar operation in public many times, and consequently believed in the certainty of the art, although he did not possess the secret of making the transmuting agent. Other chemists of the 16th century, as Agricola and Sennert, were not avowed alchemists, yet they did not oppose views respecting the transmutation of metals. The last important iatro-chemist, Tachenius, alone contended against the ennobling of metals. His instructor in Leyden, Franz de la Boe, accepted the belief of his times in regard to transmutation. In the reign of James I of England, reports were circulated that an artist, Butler, had performed several transmutations in London by means of a red powder secured from an Arabian alchemist, and later he is said to have accomplished wonderful cures with a hermetic medicine. Van Helmont attests these miracles, some of which he had the opportunity of witnessing. After chemistry had assumed its proper position as a science in the phlogistic period, and its study was neither obscured by attempts at transmutation nor limited to the preparation of medicines, many experimenters still remain convinced of the possibility of converting individual metals into another. Although alchemical work was kept secret to a great extent and was looked down upon, yet expressions of belief were far from being uncommon, even among such chemists as Robert Boyle, Johann Kunkel, Homburg, George Stahl, and Hermann Boerhaave. In his old age, however, Stahl advised and warned against the pursuit of alchemy, and Boerhaave, after considerable experimental work, showed the falsity of many of the views held by the alchemists. For example, the alchemists asserted that quicksilver could be fixed in a fireproof, metallic condition without the addition of any other substance, but Boerhaave disproved this by keeping quicksilver at a somewhat raised temperature in an open vessel for 15 years without noting any change, and when he heated the quicksilver at a higher temperature in a closed vessel for 6 months, no change was observed. Ernst von Meyer states in his History of Chemistry that after his, that is Boerhaave's time, no notable exponent of chemistry, which had now attained to the rank of a science, spoke in support of the alchemistic views. But all the greater was the number of cheats and swindlers who cultivated the lucrative field of gold making even during the 18th century. The conviction of the impossibility of transmutation, which was at that time establishing itself among scientific chemists, made its way but slowly into outer circles. Credulity and the hope of obtaining riches for nothing were the means of leading many into very doubtful paths, even so late as the end of the 18th century and the beginning of the 19th. Final echoes of the alchemistic problem, which had for so long a period of time held the cultured of every nation in a state of tension, and had even blinded eminent scientific men, only appear to have died away during the last decades of the 19th century. The statements of witnesses and conductors of alleged transmutations are often impressive and convincing, and such testimony is the strongest of the supposed evidence in favor of gold making. Probably the most interesting of such records is that contained in the Golden Calf, the World's Idol, of John Frederick Helvetius, an eminent Dutch physician, written in 1667. In his work, Helvetius narrates the fact that he received from the artist Elias a piece of the philosopher's stone the latter had in his possession, and that this piece, no larger than a grain of rapeseed, transmuted 6 drams of lead into the finest gold. This gold was then taken to a silversmith, who first mixed 4 parts of silver with 1 part of the gold. Then he filed it, put aqua fortis to it, dissolved the silver, and let the gold precipitate to the bottom. The solution being poured off and the calyx of gold washed with water, then reduced and melted, it appeared excellent gold, and instead of a loss in weight, we found the gold was increased, and had transmuted a scruple of the silver into gold by its abounding tincture. In the 17th century, it appeared impossible to doubt such testimony, and at that time it was not known that the articles made from alchemistic gold were but worthless alloys, prepared for fraudulent purposes. Among the other Hermetic philosophers and adepts of the 17th and 18th centuries may be mentioned Jean d'Espagne, author of a treatise on mystical alchemy; Alexander Cethon, who suffered from exposure of his power; Michael Sendivogius, who made gold by projection in the presence of Emperor Rudolph II at Prague, and at Varsovia and Württemberg; Boussardier, who left a powder when he died, 1 grain of which was used by Emperor Ferdinand III for converting 3 pounds of mercury into gold; Irenaeus Philalethes, Pierre Fabre, John Obereit, Lascarius, who is recorded as having changed mercury into gold and gold into silver, and Delisle. Alchemistic efforts were especially encouraged during this period at the courts of a large number of German princes, many of whom were amateur alchemists themselves, and who expended large sums of money in fostering gold making. The priests of trickery were, however, finally exposed as frauds and rogues, and a dire punishment was meted out to them almost without exception. It has been mentioned that the alchemistic ideas, with the transmutation of metals as their leading tenet, originated in Egypt, where they were first fostered by the initiates of the sacred art, and that the conversion of the sacred art of Egypt into alchemy resulted from contact with European thought and ecclesiastical mysticism. The Egyptian priests taught the unity of nature and asserted that a fundamental similarity existed between heavenly and terrestrial things. But alchemy, while its argument rested on a supposed familiarity with nature's methods and postulated an orderly and simple universe, applied moral conceptions to material phenomena and pursued a policy rich in fantastic detail, dictated by fanciful conceptions. The original and central aim of alchemy was the production of a substance which was variously designated as the philosopher's stone, the one thing, the essence, the great elixir, the great magisterium, the red tincture, the stone of wisdom, the heavenly balm, the divine water, the virgin water, the phoenix, the lion, the old dragon, the basilisk, and the carbuncle of the sun. This substance was supposed to have the power of transmuting base metals into gold, but other powers were attributed to it also, and the alchemists undoubtedly regarded it as the soul of all things. After the 8th century, the philosopher's stone was reputed to possess the power of curing all diseases and was styled the great panacea. This belief in its powers came into existence gradually, owing to the Western alchemists attaching too literal an interpretation to some of the Arabian descriptions of its powers. For instance, Gerber termed the base metals invalids which he would cure or transmute by means of the philosopher's stone. At a much later date, about 1600, it was claimed that the philosopher's stone could transform quartz into gems, change 1,000 pearls into one pearl of great beauty, and render glass malleable. It was also said to possess the power of imparting moral culture and redemption from sin. The descriptions of the one thing differ widely, and the alchemists could describe it only in contraries. Some spoke of it as a red powder, others stated that it possessed a peach-blow color, and many affirmed that it was of a gray appearance. Paracelsus described it as a very stable, red substance, transparent as crystal, pliable as gum, and yet as fragile as glass. When pulverized, it was said to resemble saffron. Philalethes states in his Brief Guide to the Celestial Ruby, "The philosopher's stone is a certain heavenly, spiritual, penetrative, and fixed substance, which brings all metals to the perfection of gold or silver, according to the quality of the medicine, and that by natural methods, which yet in their effects transcend nature. Know then that it is called a stone, not because it is like a stone, but only because, by virtue of its fixed nature, it resists the action of fire as successfully as any stone. In species it is gold, more pure than the purest. It is fixed and incombustible like a stone, but its appearance is that of a very fine powder, impalpable to the touch, sweet to the taste, fragrant to the smell, in potency a most penetrative spirit, apparently dry and yet unctuous, and easily capable of tinging a plate of metal." The processes given for preparing the great magisterium are also numerous and varied. The methods whereby the agent is itself perfected, and the processes wherein the agent effects the perfecting of the base and unperfect things, were divided into 10 or 12 gates or stages by the alchemists. The prime requisite was the securing of the crude material to be employed. This was called the materia prima cruda, terra virgineae, etc., and although it was thought to occur in very large amounts, its identity was unknown, and the procuring of this substance was considered to be the really difficult part of the undertaking. From the materia prima cruda was to be obtained the materia prima matura, a substance also known as the mercurius philosophorum or azoth, to which was then to be added auro philosophorum. This mixture was then digested at a low heat for some time without the presence of the air, in the ovum philosophicum, to procure the raven's head, or the caput corvi, a black substance which, through long digestion, becomes transformed into the swan, a white body. The latter was then exposed to a higher temperature to produce the philosopher's stone. The various gates were known as calcination, dissolution, conjunction, putrefaction, congelation, citation, sublimation, fermentation, and exaltation. The Alexandrians believed that the metals were alloys of varying composition, and consequently that the transformation of one metal into another was possible either by means of the addition of other substances or the expulsion of some present, and the Western alchemists regarded all metals as compounds. For example, Arnaldus Villanovanus and Raymundus Lullius assumed mercury and sulfur as their constituents, and the latter asserted that every substance is composed of these two substances. Under the term mercurius or mercury, the alchemists saw the cause of metallic glance and malleability, while the term sulfur was used to express the idea of transmutability and also combustibility, and the various metals were regarded as compounds of these substances in different proportions. For instance, gold, the most perfect metal, which nature was thought to form slowly in the earth, was considered to be a compound of much mercury with only a small amount of sulfur. Therefore, considering that all other metals differed from gold only in the proportions in which mercury and sulfur were present, the alchemists sought for an agent whereby these proportions could be changed and gold produced. Introspection preceding observation gave rise to the alchemistic views of the universe and natural phenomena, and to quote M. Pattison Muir, "The change from alchemy to chemistry is an admirable example of the change from a theory formed by looking inward, and then projected onto external facts, to a theory formed by studying facts, and then thinking about them." Although many of the theories of the alchemists were ridiculous and much unimportant material was accumulated by them, yet they untiringly pursued their quest. Their views were connected with their practice, and as Muir observes, "There was a constant action and reaction between their general scheme of things and many branches of what we now call chemical manufactures." The result of this was that some progress, worthy of account, was made in the knowledge of applied chemistry during the alchemistic period. Metallurgy was not the least of these. 3 new metals, antimony, bismuth, and zinc, were discovered in the second half of the age of alchemy, and the knowledge of the properties of the metals already known was increased. But few alterations were made in the methods of extracting and purifying metals. As might be expected, the greatest importance was attached to the treatment of gold and silver ores, and quite accurate balances came to be used as a result of the attention given to the yield of the noble metals. For a long time, gold was obtained in a pure condition, just as it was in earlier times, that is, by the use of lead. But later it was ascertained that it could be purified by fusion with stibnite, antimony trisulfide, and in the time of Albertus Magnus it was found that gold and silver could be separated by treatment with nitric acid. Prior to this time, the cementation process of the ancients was employed for effecting the separation of the noble metals. Silver was extracted by fusion with lead, a method in use in Pliny's time. Mercury was obtained by roasting its ores in furnaces and by distilling sublimate, mercuric chloride, mixed with caustic lime. It was used in extracting the noble metals, in gilding, and in alchemical research. Zinc and bismuth are mentioned in alchemical literature, and it would appear that zinc was used in the early medieval times. However, these metals were not used technically. Cobalt ore is also sometimes mentioned. In the 15th century, copper was prepared by immersing plates of iron in solutions of bluestone, copper sulfate. But there are no important improvements to record in the methods of extracting and preparing iron, lead, and tin. However, the various degrees of hardness and softness of iron were known at an early period, and the deportment of copper, iron, lead, and tin, when subjected to heat and to the action of acids, was studied throughout the alchemistic period. Ceramics advanced to no little degree. In ancient times, glass had been colored by adding various oxides of metals to the fused mass, but in this age it was learned that the colors could be burned in, a decidedly important discovery. It was also found that the use of glazes containing lead and tin for earthenware vessels was advantageous for certain purposes. Dyeing became better understood. Several important dyes were introduced during the alchemistic period. Orchilla, which was known in ancient Rome, was brought from the East about the 13th century, and cochineal was introduced by the Arabians. Indigo also began to be used during this period. Alum was employed almost entirely as the mordant in dyeing. Inorganic compounds were more thoroughly studied. Nitric and sulfuric acids were obtained at an early date. The former was first prepared by the distillation of a mixture of saltpeter, bluestone, and alum, but later it was found that it could be produced from saltpeter and sulfuric acid, and sulfuric acid was prepared by distilling a mixture of iron vitriol and pebbles, and by burning sulfur, after the addition of saltpeter, under a hood fitted with a side tube for the overflow of the acid produced. When sulfur is burned alone, a gas now known as sulfur dioxide is produced, and it is known that the water solution of this gas was often confounded with sulfuric acid. Gerber prepared sulfuric acid by heating alum, but failed to study its properties other than finding that it was a powerful solvent. At a much later date, hydrochloric acid was produced by heating common salt and green vitriol. This acid, which was known as spiritus salis, was mixed with nitric acid to prepare aqua regia, a strong solvent which the alchemists thought closely approximated the alkahest or universal solvent. The alchemists were acquainted with a large number of salts, of which it was thought that solubility in water was a general characteristic. Hence the term "sol" included a large number of substances and was widely distorted. The term alkali was first mentioned in the Latin writings ascribed to Gerber, but, according to von Meyer, one seldom meets in the alchemistic age with a strict distinction between potash and soda, or between their carbonates, while on the other hand, preparations of carbonate of potash, obtained in different ways, were regarded as dissimilar products. The distinction drawn by Abu Mansur between nantrum, for example, the soda found in nature as a mineral deposit, and qualia, the alkali from the ashes of land plants, is, however, very noteworthy. These names were perpetuated in the German words natron and kali. The solvent power of the lyes obtained from the carbonates of potash and soda by the addition of lime was made use of by the alchemists. Among the salts known to the alchemists were alum, which was prepared from alum shale and widely used, iron and copper vitriols, saltpeter, salmiac, and carbonate of ammonia. Saltpeter, potassium nitrate, was probably used in early times in the manufacture of fireworks. It was known in various periods of this age as sal petrosum, sal nitri, and nitrum. Salmiac, sal ammoniacum, chloride of ammonia, was originally prepared from dung, although some of the naturally occurring product of volcanic origin was used. Carbonate of ammonia was prepared by the chemists of the 13th century and was known to them as spiritus urinae. Later it was obtained from salmiac and alkali carbonate. Other inorganic compounds known to the alchemists were nitrate of silver, chloride of silver, mercuric oxide, mercuric chloride, basic mercuric sulfate, mercuric nitrate, zinc oxide, zinc sulfate, antimony trichloride, basic chloride of antimony, antimony trioxide, potassium antimoniate, arsenious acid, peroxide of iron, oxide of copper, and the lead oxides. As before mentioned, the alchemists knew that gold dissolved in aqua regia. This solution, aurum potabile, was thought to possess wonderful medicinal effects. They also knew that silver could be precipitated from a silver nitrate solution by the use of mercury or copper. The preparation of antimony from the sulfide by fusion with iron is described in several of the works ascribed to Basil Valentine. It is mentioned in these works that antimony does not possess the properties of a metal in full degree, and that it is a variety of lead. In the 15th century, antimony was used in certain alloys, and the compounds of it then known were used in medicine. Arsenic was prepared in the 13th century by the Western alchemists, who considered that it was a bastard metal. Arsenious acid was prepared as early as the 10th century by roasting realgar, and was called white arsenic. At a much later period, about the close of the medieval age, it was observed that arsenious acid occurs in the fumes from pyrites furnaces. Mention has been made of some sulfur compounds, the sulfides of mercury, cinnabar, and antimony, stibnite, among others, which were found to be valuable materials for the production of sulfur and other bodies. These were grouped together as forming a particular variety of compounds under the name of marcasite, Albertus Magnus, zinc blende, galena, lead sulfide, and iron and copper pyrites being included among them. The peculiarity which these substances had in common, that of giving off a product of such characteristic odor as sulfurous acid when roasted, may have formed the main reason for assigning them to one group. It should be remembered, however, that the production of several metallic sulfides from their components had been observed, for example, the formation of cinnabar from quicksilver and sulfur, and this may be supposed to have contributed materially to a knowledge of their composition. Realgar and orpiment were known to the Arabian physicians. The alchemists were fond of using the names of animals as symbols of certain mineral substances, and of representing operations in the laboratory by what may be called animal allegories. The yellow lion was the alchemical symbol of yellow sulfides. The red lion was synonymous with cinnabar, and the green lion meant salts of iron and of copper. Black sulfides were called eagles, and sometimes crows. When black sulfide of mercury is strongly heated, a red sublimate is obtained, which has the same composition as the black compound. If the temperature is not kept very high, little of the red sulfide is produced. The alchemists directed to urge the fire, else the black crows will go back to the nest. Organic compounds were also examined and their properties recorded. Notwithstanding the fact that the alchemists originally paid more attention to the properties of mineral bodies rather than to those of organic bodies, yet the study of the action of heat upon bodies when air is excluded, and improvements in methods of distillation led to the investigation, in a crude manner, of the products of distillation, and eventually to the discovery of definite organic compounds. Among the few organic preparations known to the alchemists, spirit of wine takes a prominent place. This compound was formerly designated by very different names. For instance, Marcus Gracchus, 8th century, calls it aqua ardens. The Latin translators of Gerber's works refer to it as aqua vitae, and others mention it as aqua vitis, mercurius vegetabilis, spiritus vivus, and consolatio ultima corporis humani. The term spiritus vini first occurs in the writings ascribed to Basil Valentine, and the name alcohol was first used by Libavius at the end of the 16th century. The symbols used to denote the metals have been referred to. Among other signs employed, instead of writing the names of substances, were the following: sulfur, triangle with an upside-down cross on the bottom; vitriol, a circle with a cross in it; fire, triangle; air, with an A; water, with an upside-down triangle; water, with two wavy lines; earth, with an upside-down triangle with a line on the bottom; aqua fortis, upside-down triangle with two lines on the sides; aqua regia, a V with a curved line on the side; aqua vitae, a V with three circles on the points; day, a circle with an angled line on the top; night, a circle with an angled line on the bottom; amalgam, an upside-down V with three lines crossing it; alembic, an upside-down V, and a right-side-up V. The Alexandrians employed two vessels in conducting a distillation, one for evaporating the liquid and the other for condensing the vapor, and this improvement resulted in the simplification of the method of manufacturing spirit of wine, and an extension of its importance in medicine and alchemy. The preparation of concentrated spirit of wine by repeated distillation and by rectification over dry carbonate of potash was described by Raymundus Lullius, who also examined the action of sulfuric acid upon spirit of wine. Spirits were generally dehydrated by rectifying at a low temperature. However, in order to condense the vapors completely, they were passed through long condensing tubes, often of an extraordinary form. At the close of the Middle Ages, the alchemists were acquainted with several ethers, which they prepared in an impure state by the action of acids on spirit of wine. One of the alchemical writers speaks of a spirit prepared in this way which has a subtle, penetrating, pleasant taste, and an agreeable smell. This probably referred to ethyl oxide, or ethyl ether, a compound prepared by various chemists in the 16th and 17th centuries. It has been mentioned that the only acid with which the ancients were acquainted was vinegar, that is, an impure wine vinegar. The alchemists, however, learned to concentrate vinegar, and it is to them that is owed the first production of acetic acid by distillation. The alchemical views concerning the formation of acetic acid from alcohol are vague, and it was frequently confounded with the acids observed in plant juices. The belief in the transmutability of metals was dismissed from chemistry when Lavoisier established the important generalization of the new chemistry, namely, that matter may be changed but neither destroyed nor created, 1770. Nevertheless, many have applied themselves to attempts at converting the bountiful metals into the agreed standard of exchange, but these experimenters have been for the most part men of limited chemical knowledge and experience, and to quote Charles Baskerville, "A careful analysis of the motives actuating and methods pursued presents merely an inferior picture of the perfected practices we are gradually learning of as obtaining in that circle termed high finance." The alchemical literature of the 19th century is quite extensive, but is, in general, Kabbalistic and teeming with credulity, misconception, and misinformation. At the present time, there is a strong inclination among chemists toward a belief in the mutual convertibility of chemically similar elements. This view is based on the supposition that all the chemical elements are combinations of different quantities of one primal element, and on the peculiar conduct of certain recently discovered elements. In fact, the belief in the transmutation of atoms is in close agreement with the present theories of atomic disintegration, but this is based on new discoveries and on correctly interpreted chemical problems, and not upon false deduction and experiment. It is, therefore, not to be confused with the earlier views, for even if the hypothetical primal element should be isolated, one aim of alchemy would be fulfilled, but the fulfillment would not be that whereof the alchemistical philosophers taught and dreamed. End of section 4.